Okay, it looks like it's doing okay. Real sorry for this. It's a bit messed up. I had to update everything but OBS for OBS to work. That's fantastic. Is this where my voice is coming in from? Okay, yeah, that's not where I want my voice to come in from. Here's where I want my voice to come in. There. Hey, can you? Oh wow, I just leaked my IP address. That's really kind of me, isn't it? I'm glad y'all saw that. And by y'all, I mean the nobody who's here. Unless somebody is here, in which case, I'm sorry. Hey, here we are. Looks like no one saw that, but it's going to be forever on my YouTube. I don't actually care that much. Right. So today we are going over error handling. Very useful thing. I myself am an error. I need to be handled. Hey, you can see me now, I think. No other notice. Hopefully that doesn't fall with everything else on my desk. There we go. My hat is gone. I am a hatless man. I have nothing to my name. Not even a hat. Right, honestly, I'm just gonna start in like a few minutes. Been reading Tress of the Emerald Sea. Kinda got lost in thought. Around 7:20, I started trying to get this to work. I had to try and update the thing, but it decided it was gonna take about 4 minutes. It took about, well, 20. Very happy to see. And I still have this. I don't know what any of this is. That seems concerning, honestly. I don't really like this thread. Insufficient data found in processing unit. Yeah, I feel that in my soul. That tends to be my case. Right, since this isn't exactly the most important thing, I assume there will be somebody coming in eventually. If so, sorry for starting without you, but that's what I'm gonna do. Errors are in fact, sorry. Errors are a fact of life in software. The Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. This requirement makes your program more robust by ensuring that you'll discover errors and handle them appropriately before you've deployed your code in production. This seems to be one of the major reasons people love Rust, because it actually forces you to understand what you're doing. Rust groups errors into two major categories: recoverable and unrecoverable errors. For a recoverable error, such as a file not found error, you most likely just want to report the problem to the user and retry the operation. Unrecoverable errors are always symptoms of bugs, like trying to access a location beyond the end of an array. And so, we want to immediately stop the program. Not very useful for the kernel. Linux kernel is having some issues with this. I believe they've been fixed for the small amount of Rust code that's in it. But this is why Rust hasn't taken over the kernel at this point. If you have an error that stops the kernel, that's millions upon millions upon millions of dollars of servers that just halt function because of a kernel update. Not a good idea. Most languages don't distinguish between these two kinds of errors and handle both in the same way, using mechanisms such as exceptions. Well, that wasn't properly spoken, apologies. Using mechanisms such as exceptions. Rust doesn't have exceptions. Instead, it has the type result P:(E) for recoverable errors and panic, and the panic macro that stops execution when the program encounters an unrecoverable error. This chapter covers calling panic first, and then talks about returning result, type error, I assume, values. Additionally, We'll explore considerations when deciding whether to try and recover from an error or simply stop execution. Alright. Unrecoverable errors with panic. Sometimes bad things happen to your code, and there's nothing you can do about it. In these cases, Rust has the panic macro. There are two ways to cause a panic in practice: by taking an action that causes our code to panic, such as accessing an array past its end, or by explicitly calling the panic macro. In both cases, because of panic in our program. I'm trying to think about something about discos and Rust code panicking. I can't think of it. I'm sorry, I'm a failure. In both cases, we cause a panic in our program. By default, these panics will print a failure message, unwind, clean up the stack, and quit. Via an environment variable, you can also have Rust display the stack, the call stack, when a panic occurs, to make it easier to track down the source of the panic. Unwinding the stack, or aborting in response to a panic. By default, when a panic occurs, the program starts unwinding, which means Rust walks back up the stack and cleans up the data from each function it encounters. However, this walking back and cleanup is a lot of work. Therefore, Rust allows you to choose the alternative of immediately aborting, which ends the program without cleaning up. Memory that the program was using will then need to be cleaned up by the operating system. That's never an issue, don't worry about that. If in your project you need to make the resulting binary as small as possible, you can switch from unwinding to abort on a panic by adding panic equals abort to the appropriate profile section in your cargo.toml file. For example, if you want to panic on abort in release mode, add this: profile.release, panic abort. Makes sense. I see no real reason why a release on a public, facing application would want abort to unwind, why you would add that space. What is a non-developer going to do with that information other than be able to reverse engineer your product at best? Or at worst, I guess. I suppose that would allow for people to give you good bug reports, though, which would be good. I wonder if there's an operation you can write yourself, like a function you can write yourself in order to allow you to change the behavior of an abort. Of a panic. I guess a new macro. Overloading the macro? Shadowing it or whatever? Hey. Function, main, panic, crash and burn. This doesn't compile. Oh, this code panics. Okay. It does compile. It panics. We've added this in. When you run this program, you'll see something like this. Cargo run, compiling, panic. Yep. Optimize debug info. Thread main panicked at crash and burn source main.rs. Note. Run with Rust backtrace equals 1 environment variable to display a backtrace. The call to panic causes the error message contained in the last two lines. The first line shows our panic message and the place in our source code where that panic occurs. Source main.rs25 indicates that it's the second line, fifth character of our source/main.rs file. In this case, the line indicated is a part of our code, and if we go to that line, we see panic macro call. In other cases, the panic call might be in our code might be in code that calls our code. And the file name and line number reported by the error message will be someone else's code where the panic macro is called, not the line in our code that eventually led to the panic call. We need the backtrace of the functions, the panic call. We can use the backtrace of the functions the panic call came from to figure out the part of our code that is causing the problem. We'll discuss backtraces in more detail next. Using a panic backtrace. I'm glad that they talked about this. I've never actually seen somebody describe this as fairly self-evident, but hey, what if there's something I've been missing this entire time? Let's look at another example to see what it's like when a panic call comes from a library because of a bug in our code, instead of from our code calling the macro directly. Listing 9.1 has some code that attempts to access an index and a vector beyond the range of its valid indexes. We got 99. That's not wanted. Attempting to access an element beyond the end of a vector, which will cause a call to panic. Here, we're attempting to access the 100th element of our vector, which is at index 99. Because indexing starts at 0. Yes, but the vector only has 3 elements. In this situation, Rust will panic. Using square brackets is supposed to return an element. But if you pass an invalid index, there's no element that Rust could return here that would be correct. And see, attempting to read beyond the end of your data structure is undefined behavior. You might get whatever is located at that memory address that would correspond to the element in the data structure, even though that memory doesn't belong to that structure. This is called buffer overread, and is a very bad thing. Passwords, strange information, random bits of data, SSH keys, etc. can be in memory at that time. If it's read and passed back to the user, you can understand that being a very bad thing, and can lead to a security vulnerability. An attacker is able to manipulate the index in such a way as to read data they shouldn't be allowed to that is stored after that data structure. This is how Heartbleed works. To protect your program from this sort of vulnerability, if you try to read an element at an index that doesn't exist, Rust will stop execution and refuse to continue. Let's try it and see. Right, we compile this. I'm just going to trust them. I don't think they're going to lie to me. Right, here's the error. Thread main panicked at index out of bound. The len is 3. The index is 99. Source / main.rs. Note that with Rust backtrace equal 1, environment variables to display a backtrace. I'm always going to read that. That's not something I need to read. This error occurs at line 4 of our main.rs where we attempt to access index 99. The next note line tells us that we can set the Rust backtrace environment variable to get a backtrace of exactly what happened to cause the error. A backtrace is a list of all the functions that have been called to get you to that point. Backtraces in Rust work as they do in other languages. The key to reading the backtrace is to start from the top and read until you see the files you wrote. That's the spot where the problem originated. The lines above that spot are code that your code has called. The lines below are code that called your code. These before and after lines might include core Rust code, and library code, or crates you've been using. Let's try getting a backtrace by setting the environment variable to 1. Any value except 0. Oh, that's lovely. They just have a check if it's 0. If it's anything else, they just run the code. It's a guard clause, I guess. That makes sense. Listing 9.2 shows output similar to what you'll see. Yeah, this is the junk they put in every single other language. A lot is behind an environment variable. Just give me the error instead of a bunch of trash. Alright, so we got 0. Rust begin unwind. Well, let's just let them talk. Now let's read this. 0, Rust begin unwind at, and then we have a blob library standard source panicking.rs. Right, looks like we have 1, 2, 3 calls to panicking.rs. That is 1, 2, 3. We have a begin unwind, panic format, panic bounce check. Wonder what this does. Core panicking bounce check. Since there's nobody here, I get to just look at random stuff, wasting my time. I'm very glad. Alright, what are we looking at? GitHub.io. Panic bounce check, file line. What do you do? There seems to be no documentation. Unstable core panic, internal details of the implementation of the panic, and unrelated macros. Right, so it just takes in a file line. Reference. I don't know what this means. Oh, it's a tuple. With a reference. I can't remember what that means. Static string. Oh, that's lifetime. Okay, that's a lifetime label. Reference to a static string and a U32. That's what the file line is. Yeah. Index, usize, and a length usize. Turns a macro. So this is just a macro. Can we see the source? The site? That's lovely. Thank you guys. That's a shame. Alright, next it goes to slice index. At just the core implementation. We got the core implementation, then we got a library for allocation. Panic at main. Right, okay. So everything outside of 7 has been. Sorry, no. Yeah, everything outside of 6 has been meaningless. That's just 3 for the panic and then a bunch for everything else. I doubt that this actually needs to be displayed unless you're working on the code itself. But hey, glad it's still there. Why not? The backtrace generated by a call to panic displayed when an environment variable is set. That's a lot of output. The exact output you see might be different depending on your operating system and Rust version. In order to get backtraces with this information, debug symbols must be enabled. Debug symbols are enabled by default when using cargo build or cargo run without the -- release flag, as we have here. The output in listing 9.2, line 6 of the backtrace points to the line in our project that's causing the problem. Line 4 of source/main.rs. If we don't want our program to panic, we should start our investigation at the location pointed to by the first line mentioned in the file we wrote in listing 9.1, where we deliberately wrote code that would panic. The way to fix this panic is to not request an element beyond, don't fuck up. I'm thankful that you spent an entire paragraph saying, hey, we should probably look where the problem exists and not just cause the problem. When your code panics in the future, you'll need to figure out what action the code is taking with what values to cause the panic and what the code should do instead. What a shock. Honestly, I'm shaken. I'm shook even. This is amazing. Who would have guessed? We'll come back to panic and when we should and should not use panic to handle error conditions in the to panic or not to panic section later in this chapter. At least I got a sense of humor. Next, we'll look at how to recover from an error using result. That's the quiz. What is the name of the environment? Oh god, I cannot remember that. Yeah, I'm not going to get that. I'm just not going to get that. Rust. Trace? Sure. Which of the following is not a good reason to use a panic? The program has reached an error state, which should be communicated to a caller function. That's a bad way to put it because it kills the program. The program should stop executing as soon as possible, as it reached an unrecoverable error state, is about to perform a dangerous operation. All of these are good reasons. That is not a good reason because the program terminates. Oh, I got that correct. Wow, I'm shocked. Good naming, I guess. Intuitive. Next, unrecoverable errors with result. Most errors aren't serious enough to require the program to stop entirely. Sometimes when a function fails, it's for a reason that you cannot easily interpret and respond to. For example, if you try to open a file and that operation fails because the file doesn't exist, you might want to create the file instead of terminating the process. Recall that from error handling potential failures with result, chapter 2. Recall from handling potential failures with result in chapter 2 that the result enum is defined as having two variants, OK and error, as follows. Yep. The T and E are generic type parameters. We'll discuss more in chapter 10. What you need to know right now is that T represents the type of the value that will be returned in a successful case with the OK variant, and E represents the type of the error that will be returned in a failure case within the error variant. Because result has these generic type parameters, we can use the result type and the functions defined on it in many different situations, where the successful value and errors value we want to return may be different. Let's call a function that returns a result value, because their function could fail. In listing 9.3, we try and open a file. Alright, open hello.txt. The return type of file open is result TE. Generic parameter T has been filled in by the implementation of file open, with the type of the success value standard fs file, which is a file. The type of E used in the error value is standard IO error. This return type means the call to file open might succeed and return a file handle that we can read from or write to. Function call also might fail, for example. This file might not exist, or we might not have permission to access the file. File open function needs to have a way to tell us whether it succeeded or failed, and at the same time give us either the file handle or an error information. This information is exactly what the result enum conveys. In the case where file open succeeds, the value in the variable reading file result will be an instance of OK that contains a file handle. In the case where it fails, the value in greeting file result will be an instance of error that contains more information about what kind of error has happened. We need to add to the code in listing 9.3. We take different actions depending on the value file open returns. Listing 9.4 shows one way to handle that with a match result. We have OK, file, or we just panic. From open the file, here's the error, pass in the error. Note that, like the option enum, the result enum and its variants, I'm just going to increase this size up here because, y'all can't see beside my face, can you? Yeah, there we go. And let's make this a little bit bigger. Good stuff. Note that, like the option enum, the result enum and its variants have to be brought into scope by the prelude. So we don't have been brought into scope by the prelude, so they're already there. We don't need to specify result before OK and error variants in the match arms. That's good to know. When the result is OK, the code will return the inner file value out of the OK variant, and we then assign that file handle value to the variable greeting file after the match. We can use the file handle for reading or the other arm of the match handles the case where we get an error by simply panicking. We'll see this following code. Problem opening the file OS. Code 2. Time. Not found. Message. No such file or directory. Oh, okay, so we're going to open it up. I assume that within this we'll have some parameter here. We can probably take this out and just check against code 2. As usual, this output tells us exactly what has gone wrong, matching on different errors. Code in listing 9-4 will panic no matter why file open failed. However, we want to make different actions for different failure reasons. If file open failed because the file doesn't exist, we want to create the file and return the handle to a new file. File open failed for any other reason, for example because we didn't have permission, we still want the code to panic in the same way it did as in listing 9.4. For this, we add an inner match expression shown in listing 9.5. Alright, so we use standard file, error kind. We add in, yep, okay. So we have let greeting result, yep. We're matching the result against this. Okay, file is a file. Okay, error, we output a match against error.kind, taking the kind of error out. If it is error kind not found, we match file create hello.txt. Okay, yeah, so we're trying to create it, and if it creates the file, it'll pass, well, either way, it'll pass back a result to match. So if it's successful, on OK, FC, we output FC. FC will be output from this match statement here, making greeting file FC, which will be the resultant file. I can never remember the name. The handle for the file. If there's an error, problem creating the file, and then output the error. If there's another error, problem opening the file. and we output that error. I wonder what kind of error that could be. So here we just say, hey, if it's okay, give us the file. If it's not, check what kind of error it is. Match against it. If it is a not found error, match against the output of creating a new file called hello.txt. If that works, pass back fc, which is the new file handle or file created, the new handle of the file which has been created. If you can't create it, panic because it doesn't work. If anything else goes wrong, if anything goes wrong in the, there is another kind of error, we simply panic. So that would be if we don't have permission to write it, or perhaps if it's read-only. The type of the value that file open returns inside the error variant is IO error, which is a struct provided by the standard library. This struct has a method kind that we can call to get an IO error kind value. The enum IO error kind is provided by the standard library and has variants representing the different kinds of errors that might result from an IO operation. The variant we want to use is error kind not found, which indicates the file we're trying to open does not exist. So we match on the greeting file result. I'll also have an inner match on error.kind. Condition we want to check in the inner match is whether the value returned by error.kind is the not found variant on the error kind enum. If it is, we try and create the file with file create. However, because file create could also fail, we need a second arm in the inner match expression. When the file can't be created, a different error message is printed. The second arm of the outer match stays the same. The program panics on any error besides the file missing error. Alternatives to using pattern match with result. That's a lot of match. Yeah, it is a bit confusing. The match expression is very useful, but also very much a primitive. In Chapter 13, you'll learn about closures, which are used with many of the methods defined on result.de. These methods can be more concise than using match when handling results in your code. For example, here's another way to write the same logic as shown in listing 9.5. This time using closures and the unwrap or else method. Alright, main greeting file open, hello.txt dot unwrap or else. We bring an error with this syntax, two pipes, right? If we just have a basic if statement. If error.kind equals error kind not found, file create, hello.txt unwrap or else, error panic. Okay, yeah. So, I see. I do actually see. Right, so we have file open, unwrap or else is a full-on function with the error variable being taken in if there is an error. So either A, hello.txt works, and it's an OK variant, and it unwraps. We get the OK variant, we get the handle, which is now equal to greeting file. Greeting file equals the OK variant, or we have this function, bringing in the error as a variable. If error.kind is equal to exactly this enum, we attempt to create this file. File create, unwrap or else. Again, if this works, we simply pass it back. This is that's really nice of you. We simply output this. This is what is it called? Well, you don't say return, but it actually does return anyway because we hate you. This brings it back. Hello.txt is passed back to blank, and blank simply goes down to greeting file since this is an expression. It will return file.create hello.txt's output, which will be a handle here. The else as the error variable from creating the file, error. There we go. Else we panic. Although this code has the same behavior as listing 9.5, it doesn't contain any match expression, and is cleaner to read. Come back to this example after you've read Chapter 13, and look up the unwrap or else method in the standard library documentation. Any more of these methods can clean up huge nested match expressions when you're dealing with errors. That's good to know. Quiz. Which of these statements best describes why file open returns a result and not an option? Because result represents the possibility of failure, while option cannot represent failure. I think option can represent failure, because result can represent why an operation failed, and file opening can fail for many reasons. I think that might be the issue. Because result uses fewer bytes at runtime? I don't know. Good? I doubt it does. I think it probably uses more. Because result represents errors the same way as the underlying system calls. Nope, I think that this is the reason, because it can represent why. Correct. Shortcuts for panic on error. Unwrap and expect. Using mash works well enough, but it can be a bit verbose and doesn't always communicate intent well. The result, TE, type has many other helper methods defined on it to do various more specific tasks. The unwrap method is a shortcut method implemented just like the match expression we wrote in 9.4. If the result value is the OK variant, unwrap will return the value inside of OK. If the result is an error variant, unwrap will call panic macro for it. Here is an example of unwrap in action. Right, yep. Let grading file equal hello.txt.unwrap. So if that's okay, we'll just get the file handle right here. If we run this code without the hello.txt file, we'll see an error message from the panic call that the unwrap method makes. Thread main panic at called result unwrap on an error value. And then here's the error value. Find not found message, no such file. Correct. Similarly, the expected method also lets us choose the panic error message. Using expect instead of unwrap, providing good error messaging can convey your intent and make tracking down the source of a panic easier. The syntax of expect looks like this. We have file.open, hello.txt.expect. Hello.txt should be included in this project. Okay, so that's just going to give us the message to panic with. We use expect in the same way as unwrap to return the file handle or call the panic macro. The error message used by expect, and it's called the panic, will be the parameter that we pass into expect rather than the default panic message that unwrap uses. Here's what it'll look like. Yep, no such file or directory. Well, that's a little bit nicer for the user. Good to see. That's probably how a lot of this stuff works when I horrifically fail. In production quality code, most recitations choose expect rather than unwrap and give more context about why the operation is expected to always succeed. That way, if your assumptions are ever proven wrong, you have more information to use in debugging. Okay. Propagating errors. When a function's implementation calls something that might fail, instead of handling the error within the function itself, you can return the error of the calling to the calling code so that it can decide what to do. This is known as propagating the error and gives more control to the calling code, where there might be more information or logic that dictates how the error should be handled and what you have available in the context of your code. Great for writing libraries. For example, listing 9.6 shows a function that reads a username from a file. If the file doesn't exist or can't be read, the function will return those errors to the code that calls the function. We have standard files, standard IO, self, and read. Self. Oh yeah, bring in standard IO as well as the read thing from IO. Read username from file, we have result. Right, yeah, so the function will just return a result. That's what I was thinking would happen. Result with some string type and IO error. I'm guessing the string will be the actual issue at cause here. Right. Let username file result equal file open hello.txt. If that exists, it'll give an OK. If it doesn't, it'll give a error. Let mutable username file match username file result. If it's OK, let the output equal file, and then, well, I'm guessing that this simply returns file. Well, not guessing. This returns file to username file. Let mutable username equal a new string. Sorry, an error will in fact simply return the error. That's it. It'll return, wrapped inside of the error, whatever the error was inside of the new error, I guess. It'll return a result enum variant called with the error brought in from the initial result enum variant Let mutable username equal new string match username dot file. Username file read to string. Right, so username file read to string, passing in mutable username. Read to string. Okay, I'm assuming read to string simply takes a file handle and then reads it all out to a string. It takes the original file, reads it out, puts it into a string. That is meaningless to me. Sorry, somebody just sent me a Discord link and no other information. Since there's nobody here, I get to take my time and read it out. I think I can assume what this is. It could be a threat. I'm scared. Oh, no, it's Curse of Strahd. I'm guessing I was the chosen one. Fantastic to read. Anyway, I think we understand what's going on here. This function can be written in a much shorter way, but we're going to start by doing a lot of it manually in order to explore and/or handle it. At the end, we'll show the shorter way. Let's look at this return type of the function first. Result, yep. This means the function is returning a value of the type result, type E, where the generic parameter T has been filled in with a concrete type string, and the generic type E has been filled in with a concrete type IO error, because it can only return a string or an error. For the first bit, it can only return a string, which will be the file handle, or well, it'll be the username actually. Or separately, it can only return an IO error in the error section. It can't return any other form of error. Sorry. If this function succeeds without any problems, the code that calls this function will receive an OK value that holds a string. The username that this function reads from the file, or that is the output. String will be the username the function reads from the file. If this function encounters any problems, I hate this, the calling code will receive an error value that holds an instance of IO error and contains more information about what the problems were. We chose IO error as a return type of this function because that happens to be the type of error provided by the operations we're calling. Yep. In this function body, that might fail. File open function and read to string method both will give out an IO error. The body of the function starts by calling file open function. Then we handle the result value with a match similar to the match in 9.4. If it succeeds, the file handle in the pattern variable file becomes a value in the mutable variant username file. And the function continues. In the error case, instead of calling panic, we simply pass back the error to the caller. To return out of the function entirely and pass the error value from file open now in the pattern variable E back to the calling code of the function's error value. So if we have a file handle in username file, function that creates a new string in the variable username, calls out read to string method on the file handle, reads the contents to the username. The read to string method also returns a result because it might fail even though file open succeeded. So we need another match to handle the result. If read to string succeeds, then our function has succeeded and we return the username from the file that's now in username, wrapped in an OK. If read to string fails, we give back the error as before. However, we don't need to explicitly say return because this is I hate that, stop that, go away. The code that calls this code will then handle it itself. I think we understand this. This is quite explicit. It's up to the calling code to decide what to do with those values. If the calling code gets an error value, it could panic and crash the program. Use a default username or look up the username from somewhere other than a file. For example, we don't have enough information on what the calling code is actually trying to do, so we propagate all success and error information upward to handle it appropriately. The pattern of propagating errors is so common in Rust that Rust provides the question mark operator, to make this easier. Okay. A shortcut for propagating errors, the question mark operator, shows the implementation of read username from file that has the same functionality, But this implementation uses the question mark operator. Much smaller. Look at this. Let mutable username file equal. Just like question your call. I like that. That's kind of funny. He's like, I'm not certain this will work. File open hello.txt? Who knows if it'll work? Anyway, let's try it out. Okay, that's kind of funny. I like that. That simply returns the error, but I'm guessing it will error out if we try and use this when we're not using result variable as a return. The question mark after result is defined to work in almost the same way as the match expression we defined to handle the result values in listing 9.6. If the value of result is an OK, the value inside of the OK gets returned from this expression, and the program will continue. If the error is an error, it will be returned from the whole function as if we had used the return keyword with the error. There is a difference between what the match expression from listing 9.6 does and what the question mark operator does. Error values that have the question mark operator call on them go through the from function, defined in the from trait in the standard library, which is used to convert values from one type to another. When the question mark operator calls the from function, the error type received is converted into the error type defined in the return type of the current function. This is useful when a function returns one error type to when a function returns one error type to represent all the ways a function might fail, even if parts might fail for many different reasons. For example, we could change the read username from file function in listing 9.7 to return a custom error type named our error that we define. If we also define implement from error.io for our error to construct an instance of our error from error.io, then the question mark operator calls in the body of a read username from file, will call from and convert the error types without needing to add any more code to the function. That is really cool. I quite like that. I'm glad that I didn't decide just to skip through this. I skimmed through it well enough, but I'm glad I read this. This is very useful. In our context from listing 9.7, the question mark at the end of the file open call will return the value inside an OK, the variable username file. If an error occurs, the question mark operator will return early out of the whole function and give an error value to our calling code. The same thing applies to the question mark at the end of a read to string call. The question mark operator eliminates a lot of boilerplate and makes this function implementation simpler. We could even shorten this code further by chaining method calls immediately after the question mark, as shown in listing 9.8. Yep, this is now 3 different pieces. Okay, yeah, let mutable username equals string new, file open hello.txt if works, read string. Yeah, that's cool. Alright. I quite like that. So we can chain onto it. So this will either return or separately pass it back, which then it uses the dot operator here and runs some other code on the resultant variable or value. We've moved the creation of the new string and username to the beginning of the function. That part hasn't changed. Instead, the creation of a new variable username file. Instead of the creation of a variable username file, we've chained the calls into read to string directly onto the resultant of file open hello.txt. We still have a question mark at the end of read to string call, and we still return an OK value containing username when both file open and return to string succeed, rather than returning errors. This functionality is again the same as in listing 9.6 and 9.7. This is just a different, more ergonomic way to write it. Listing 9.9 shows a way to make this even shorter using the file system read to string. Hey, okay. Okay, that's great. So we return, right, so read to string is the same thing. Read username from file is just an implementation of read to string. But it specifically states, well, yeah. Well, I guess read to string probably passes back a result that isn't as strict as ours. Okay. Reading a file into a string is a very common operation, so the standard library provides the convenient file system read to string function that opens the file, creates a string, and reads the contents of the file, puts the contents into that string, and returns it. Of course, using file system read to string doesn't give us the opportunity to explain all the error handling, so we did it a long way for. Makes sense. Where the question operator can be used. Question mark operator can only be used in functions whose return type is compatible with the value question mark is used on. This is because the question mark operator is defined to perform an early return of a value out of the function, in the same manner as the match expression we defined in listing 9.6. In 9.6, the match was used being a result value, and the early return arm returned the error value. The return type of the function has to be a result, so that it's compatible with this return. Listing 9.10, we'll look at the error we'll get if we use the question mark operator in a main function with a return type incompatible with the value for the type of, Right, so, reading file open, hello.txt, and we got this question mark, and this little guy is very confused. What does that say? This code does not compile. This code opens a file which might fail. The question mark operator follows the result value returned by file open. But this main function has the return type of nothing, not result, or an empty tuple, not result. When we compile this code, we get the following error message. Alright, the question mark operator can only be used in a function that returns result or option, or another type that implements from residual. Okay. This function should return result or option to accept question mark. So we can use this on an option. That's good to hear. Let greeting file equal, and then here's the place where it is utilized. Cannot use the question mark operator on something that returns an empty tuple. Help. Here's the help. For more information, try running that. This error points out that we are only allowed to use the question mark operator in a function that returns result, option, or another type that implements from residual. To fix the error, you have two choices. One choice is to change the return type of your function to be compatible with the value you're using the question mark operator on, as long as you have no restrictions preventing that. The other technique is to use a match or one of the result TE methods to handle the result TE in whatever way is appropriate. The error message also mentioned that question mark can be used with option values as well. I noticed that. That's cool. As with using question mark on result, you can only use question mark on option in a function that returns an option. Yep. What? You can only use question mark on option in a function that returns an option. Yep, that makes sense. Sorry. Yeah, that does make sense. The behavior of the question mark operator when called on an option is similar to its behavior when called on a result. Value is none, and none will be returned early from the function at that point. If the value is sum, the value inside of sum is the resulting value of the expression, and the function continues. Listing 911 as an example of a function that finds the last character in the first line in given text. Text.lines next, question mark, if there is something that's next, stars. Last. Okay. Turning an option of type char. Containing a char. This function returns option char because it's possible that there is a character there. It's also possible that there isn't. This code takes the text string slice argument and calls the lines method on it, which returns an iterator over the lines in the string. Because this function wants to examine the first line, it calls next on the iterator to get the first value from the iterator. If text is the empty string, this call to next will return none. In which case, we use a question mark to stop and return none from the last char of first line. If text is not the empty string next return a sum value containing a string slice of the first line in text. Question mark extracts a string slice, and we can call chars on that string slice to get an iterator of its characters. We're interested in the last character on this line, so we call last to return the last item of the iterator. This is an option because it's possible that the first line is the empty string. For example, if text starts with a blank line, but has characters on other lines, as in /n, hi. However, If there is a last character on the first line, it will be returned in the sum variant. The question mark operator in the middle gives us a concise way to express this logic, allowing us to implement the function in one line. If we couldn't use the question mark, we'd need another variable to store that, check against it, and then continue operation. Yep. Note that you can use the question mark operator on a result in a function that returns result, and you can use a question mark operator on the option that returns an option, but you can't mix and match because you can't return one or the other. The question mark operator will automatically convert a result to an option or vice versa. In those cases, you can use methods like the OK method on result or the OK or method on option to do the conversion explicitly. So far, all the main functions we've used return empty tuple. The main function is special because it's that's not an empty tuple, it just returns nothing. This is the entry and exit point of executable programs, and there are restrictions on its return type and what it can be for the programs to behave as expected. Luckily, main can also return a result. Listing 9.12 has code from listing 9.10, but we've changed the return type of main to be result and to tuple with a box dine error. Don't know what dine error means. And added a return value OK to the end. This code will now compile. Okay. The box dine error is a trait type, which we'll talk about in using trait objects to allow values of different types. Section in chapter 17. That's quite a while away. For now, we can read box dine error to mean any kind of error using a question mark on a result value in the main function with the return error. Box dine error is allowed because it allows any error to be returned early. Even though the body of this main function will only ever return errors of type standard error IO error by specifying box dine error, this signature will continue to be correct even if more code that returns other errors is added to the body of main. When a function returns a result, tuple E, the executable will exit with a value of 0 if main returns OK. Will exit with a non-zero value if main returns an error value. Executables written in C return integers when they exit. Programs that successfully exit return 0, and programs that error return some integer other than 0. Rust also returns integers from executables to be compatible with this convention. The main function may return any type that implements standard process termination traits, which contain a function report that returns an exit code. Consult the standard library documentation for information on termination trait for your own dice. Now we've discussed the details of calling panic or returning a result. Let's return to a topic: how to decide which is appropriate and which to use in what case. Given an arbitrary expression E of type result T, E, which code snippet best represents how E is translated? We match against E. Right, given an arbitrary expression E of type result, yep. Which code best represents how E is translated? What? I actually just don't understand what this means. Of type result T, E, which code snippet best represents how E is translated? What? So we have an expression like IO : error or something like that. What do you mean is translated? What the fuck do you mean? What? Sure. Match E. Oh, I'm just gonna say this because I'll admit, don't know what it means. I'm assuming it's this because it returns X, the value, within an OK, or the error of type error, and then simply returns the error. Sure, whatever. It's that. Determine what the program will pass the compiler and write the expected output. We have a mutable username file equals file open hello.txt, immutable username string new, username read to file, read to string, mutable username. Some username. assume hello.txt has the context will. Alright. We are calling this within a print statement and then unwrapping, which may cause an error if it fails. We have mutable file open equals file open hello.txt, which will either return an error, which will crash the program, or open it. It will not crash the program because it's file open and it does exist with contents will. We have let username equals string new, username file dot read to string, a mutable reference to username, or an error. Right, yep, so we are simply changing the file. Yeah, so we're adding to username contents of the username file. That seems fine, I see no issue with this. Some username, returning the some username because it's an option. I read username.file.unwrap. I see no problem with this, it should return will. Yep. We'll see if I'm wrong. It won't have an enter. Make it clear. That's wrong. It will not compile. Why? File open returns a result, but that's an option. Returns a result. The return type of read username from file expects an option. Therefore, it's invalid to use the question mark operator. Yep. Okay, I wasn't looking towards that. It did tell me that explicitly, but as you guys have been seeing, I've been going through this fairly quickly, due to some various reasons. Right, actually, I think this is about where I'm going to end it. The error here is that this exits with a result. It returns a result, but we are returning an option. The error will tell us quite explicitly what the issue is. I think that's about it for tonight, however, so goodbye. Have a great day. I love you all. I don't know what to say in these situations. How short is this? We'll get through this next time. We'll get to